Welcome everyone. The question is, a long straight wire of radius A carries a steady current I. The current is uniformly distributed across its area of cross section. The ratio of magnitude of magnetic field B1 at A by 2 and B2 at 2A. Then you have to find it out the ratio of these two. That means B1 by B2. The options are given, that is 1 by 2, 1, 2 and 4. So let us try to understand this thing first, and after that we will find it out what is B1 and B2. Obviously this is an applications of the Ampere's circuital law. Okay. So let us say this is a wire, and through this wire the current flows. That current is capital I, and this is the cross sectional area of the wire, we can say. And through this cross sectional area the current density, that is we can say the J, that is the capital I divided by A, that is constant, that is uniform. And if I consider this is the axis of the wire, then we can say this is the radius of the wire. Now at two different points we have to find it out the magnetic field. Now if I say that this is the wire and this is the axis of the wire, and we have to find it out the magnetic field at the point P, which is at a distance R1 from the axis of the wire, and the current flowing through the wire is I, then according to the Ampere's circuital law we can consider an Amperian loop like this. We can consider an Amperian circular Amperian loop like this, and that will be cyclic integral B dot dl, that is line integral of the magnetic field, and that is equal to the mu naught I enclosed. What is mu naught? Mu naught is obviously the magnetic permeability, and I enclosed is the current enclosed by the Amperian loop of radius R1. And one thing to be pointed out, that the point where we want to find it out the magnetic field, the radius of the circular loop are same. That means the point of observation or point of finding the magnetic field is on the Amperian loop. Now the magnetic field at each and every point, just like if I consider an small elemental and let us like this is the dl, and this dl is in that direction. Since according to the right hand rule, okay, right hand rule, we can say if you place your thumb along the directions of the current, and if you curl your all the fingers, then it shows the direction of the magnetic field. Then according to that, the magnetic field at each and every point on the Amperian loop is tangential, and it is at the same direction as that of the dl. So we can say B and dl are parallel to each other. So we can say B dot dl is B dl cos 0 degree, and since cos 0 degree is 1, so we can say it is simply B dl. Now let us come back to the I enclosed. What is I enclosed? Here the Amperian loop encloses a total current, so I enclosed is equal to I, and so it is the equation. Now in this equation, see this B, this magnetic field is constant at each and every point on the Amperian loop, so it can be taken outside the integration. So we can say B is outside the integration, so cyclic integral dl is equal to mu naught I. Now what is dl? dl is the elemental length of the amperian loop of radius r1. So if I just integrate it, it will be 2 pi r1. So this will be b multiplied by 2 pi r1 equal to mu naught into I. So b is equal to mu naught into I divided by 2 pi into r1. Now if this point of observation where we want to find it out the magnetic field, that point is inside this wire, that is somewhere here. If this is at a distance r2, then obviously we will consider an amperian loop of radius r2. Okay, now obviously this amperian loop of radius r2 is less than that of the cross section area capital A. Obviously then the current which is passes through this amperian loop r2 is not exactly equal to the capital I. Then I enclosed will be there. Okay, so what is the I enclosed? If I want to find it of the magnetic field at the point r2 by using the amperian loop, that will be J, what is the current density, multiplied by the area of the loop. What is J? J is I by A. We have already discussed about it, and that is pi multiplied by A square into R2 square. So here this is the thing. Yes, pi is here, so pi cancels out. So I multiplied by R2 square divided by A square. Now I simply apply this Ampere's circuital law again, that is B dot dl equal to mu naught I enclosed, and obviously this Amperian loop for this particular point we can say which is at a distance r2 and which is inside this wire. So for the obvious reasons that B and dl are parallel to each other, cos 0 degrees there, what I have discussed just earlier, and B can be taken outside the loop. So simply we can get B into 2 pi r2. I am not discussing that because I have just discussed it for the previous case. So it is mu naught, and I enclosed is I r2 square divided by A square. So from that B equal to mu naught into I r2 square divided by A square multiplied by 1 by 2 pi r2. This r2 and this square cancels out. So we can say mu naught I r2 divided by 2 pi into A square. So magnetic field at any point outside the wire, that is BO, we can say mu naught I divided by 2 pi r1, and magnetic field at any point inside the wire, it is mu naught into I r2 divided by 2 pi into A square. Now if I place these both of the things here, when the magnetic field is B1, then the magnetic field is inside, and inside that means R2, let me check, that is R2, that is this equation is valid for inside. R2 is equal to A by 2. R2 equal to A by 2. So that will be mu naught into I. In the place of R2 I am placing A by 2 divided by 2 pi multiplied by A square, and the magnetic field B2, this is B1, magnetic field B2, if I want to find it out, then we have to obviously place in the expression of outside, that is R1 is equal to 2A, and that is mu naught into I divided by 2 pi multiplied by 2a. Okay, so if I just do the ratio of these two, that is b1 divided by b2. b1 is mu naught I a, these two and these two, so it becomes 4 pi a square. So I am writing down from this equation, and the inversely proportion of b2, that is we can say that will be mu naught into I into 4 pi multiplied by a. So just see here, everything cancels out. 4 pi 4 pi cancels out, a and a square is here, cancels out, mu naught I cancels out. So the ratio becomes 1. So option B is the correct option.